Welcome to clickmyproject.com. Title of our product is RoBA Multiplier, a rounding based approximate multiplier for high speed yet energy efficient digital signal processing. Abstract of our process is, in this process we propose an approximate multiplier that is high speed yet energy efficient. The approach is to round the operands to the nearest exponent of 2 value using rounding operation. This way to computational intensive part of a multiplication is omitted to improving the speed and energy consumption at the price of the small error. The proposed approach is applicable to both signed and unsigned operations. The efficiency of the proposed multiplier is evaluated by comparing its performance with those of some approximate and accurate multipliers using different design parameters. The computational intensive part of a multiplier is omitted for a improvement of process. In this process, adder will be run based on the Keystone algorithm. The shift acts as a product of the rounding operation and signed input signal. Find out the obtained from the signal set of operation from the two input signal. They are subtracted signal and signed input signal. Now we are going to discuss about the flow diagram of our product. In our product, flow can be implemented using the four different important models. They are rounding operation and shifter, adder and subtractor. The rounding operation will be used for the rounding the exponential operand value of the signal. Signed detector. Signed detector used to detect the signed pulse waveform or the input signal. If you apply the negative input pulse, they can be directly changed in the signed waveform in the signed detector. The signed detector output can be directly applied into the shifter. The shifter can be used to shift the operation to shift the values on right justified and left justified. After the rounding function, they are also to applied into the shifter to shift the operation. The adder used to adding the two function using Keystone algorithm. The subtractor also acts as a subtracting function to near to the XOR operation. The shifted and added output signal directly applied into the subtractor. The subtractor output will be finally applied into the signed set. This signed set will be store the output waveform of our RoBA multiplier. The signed bit only store the signed input signal of our process. They only contain the positive integer. They can be run based on the 3 cross 2 power n operation. The n denotes the number of input in our process. Now we are going to discuss about the running procedure of our product. In our product can be implemented using a project navigator, ISC silence tool. Now double click to open the tool window to create a new project. Create a new project using file option, file, new project to in order to assign our design name using this name option and location in this location option and working directory. Now our source code is working directory will be assigned on this working directory option. Copy paste your path of our file. After assigning our name and location of the directory, click next to create your process. After completed to create a project, using project option to click a new source to write a program. After creating the project, they are all the process to open and create a project in our process of Xilinx ISC project navigator 14.2 tool version. In our process, our module can be named as a main. Main can be include all process there, routing, shifter, adder, subtractor and sign set. In this included full file, select the simulation to select our modulation to checks index. Checks index in the sense check the syntax in the our coding. After completed the checks index, simulate our behavior model of process. Assign the input using this. I denote the input of signal, O denotes the output of signal. Assign the input of our process using right click to force constant binary value. 4-bit binary value apply into this process. Similarly apply into input B. After apply the input of A and B, simulate our process using run this specification toolbar. This is our output of our process. A sign out is on a final output of the process. Thank you for watching this video.